Hi, we are Spartan. Wi-Fi 7 is one of the hottest topics in networking today. And in this video, we will briefly introduce the technologies what Wi-Fi 7 brings to us. First, let's take a look at the evolution of IEEE 802.11 below together. Since 1997, IEEE 11 has been continuously evolving from IEEE 802.11b to IEEE 802.11be, which is the latest technology for today's topic Wi-Fi 7. With the advancement of the IEEE 802.11, the application scope gradually becomes more extensive. With the modulation evolving from DSS to OFDMA, frequency can be applied across 2.4 GHz, 5 GHz, and 6 GHz. Operation bandwidth becomes wider to 320 MHz. Data rate have evolved to 46.1 gigabits. Here, we list several features possessed by Wi-Fi 7. Compared to the Wi-Fi 5 IEEE 802.11ac, the maximum operation bandwidth has expanded from 80 MHz to 320 MHz. (1496) is also one of the most representative features of Wi-Fi 7. It brings high spectral efficiency and capacity. For NU-MIMO, Wi-Fi 7 extends the maximum number of the downlink users to 16. That means Wi-Fi 7 devices can serve more users simultaneously. Before Wi-Fi 7, devices only allowed users to transmit on a frequency band, which could lead to insufficient throughput and delay issues. However, Wi-Fi 7 has capability of transmitting on multiple frequency bands by aggregating bandwidth, resulting in a more stable connection and increased transmission speed when users are connecting. As mentioned earlier, Wi-Fi 7 supports 6 GHz application. Currently, the approval of 6 GHz frequency band worldwide can be categorized into two main types. First operation range is 5925 MHz to 7125 MHz, followed by the FCC regulation. Another one is 5925 MHz to 6425 MHz, followed by the ETSI regulation. Spartan commits to providing customer new technology certification and collaborating with many chipset manufacturers. Thus, Spartan has achieved many world's first certification. In 2022, Spartan collaborates with Broadcom to acquire the world's first Wi-Fi 7 module FCC certification. In 2023, Spartan collaborates with ASUS to acquire the world's first Wi-Fi 7 indoor AP FCC certification. In the same year, Spartan also collaborated with Xiaomi to obtain the world's first Wi-Fi 7 mobile phone certification. In 2024, Spartan has achieved numerous standard AP FCC certifications. Wi-Fi 7 devices also support multi-RU and channel puncturing function. We will briefly introduce those two new technologies on the following slides. We have categorized the corresponding specification according to the different product type in the table below. Multi-RU and channel puncturing function are not mandatory for master devices. It's optional. However, client devices default to supporting both functions. By the way, channel puncturing supports bandwidth higher than 80 MHz only. Compared to the early application, Devices can only provide entire spectrum at a certain point in time. instead of distributing spectrum to multiple users according to the individual utilization. Here is an example of a resource unit allocation for 320 MHz. 80 MHz is distributed to 3 users based on their needs. Once user 1 requires an increase in transmissions, device will allocate additional 40 MHz to user 1 for meeting user 1's requirement. Dynamic preamble puncturing will disable the adjacent block once it is interferes with. You can see the picture when it interferes with by the second RU 40 MHz. The device will turn off the adjacent bandwidth to reduce the operation from 320 MHz to 160 MHz. Static preamble puncturing will only disable the interfered bandwidth. Hence, static preamble puncturing may utilize spectrum more efficient than dynamic preamble puncturing once receiving the interference. During the TCB workshop slide in October 2022, FCC lists some requirements for channel puncturing which have to meet the compliance. Additionally, FCC also lists the relevant requirements for AO211BE multi-RU. Based on these documents, channel puncturing and multi-RU are mandatory to assess when applying the certification. We list the large size multi-RU defined for downlink and uplink transmissions in the non-OFDNA format. 242 tone means 20 MHz, 484 tone means 40 MHz, and 996 tone means 80 MHz. In the 80 MHz, the combination includes 484 tone plus 242 tone. In the 160 MHz, the combination includes 996 tone plus 484 tone, or 996 tone plus 484 tone plus 242 tone. As to the 320 MHz, it consists of different numbers of 996 tone and 484 tone. We have summarized the patents mentioned, totaling 40 modes, along with the FCC requirements. Therefore, the addition of these extra patents is unavoidable. Next, let's proceed to a sample video clip. We will demonstrate some modes. With the different types of the mode, you can gain a clear understanding of the actual application scenarios. Except FCC, ETSI also established regulation for multi-RU mask emission in the draft EN 301-893 and the EN 303-687. In the picture, we can find that the limit varies for different patents. We also demonstrate some samples. Compared to the full RU limit, we can clearly observe that multi-RU testing becomes more complex. Finally, let's summarize today's introduction on Wi-Fi 7. 6 GHz support bandwidth extends to 320 MHz. Additional multi-RU and puncturing mode are mandatory when applying the certification. Wi-Fi 7 shares the same regulatory standards with Wi-Fi 6E. Thanks for watching. We are Spartan. We always provide the best, professional, efficiency, and the newest information. If you like our video, don't forget to like, subscribe, and share, and hit the notification bell. We are looking forward to seeing you in the next video.